My name is Dr. Sudhir Raj. I have done MTech and PhD in mechanical engineering from IIT Kharagpur. I had worked in VIT Vellore as senior assistant professor. I had taught various subjects such as robotics, mechanics, dynamics and control, and manufacturing science. I am working in the area of robotics with a specific interest in the area of non-linear control of under-actuated systems such as unmanned aerial vehicle robot, humanoid robot. Presently, I am working in SRM University, Andhra Pradesh as senior assistant professor. And my the details are given in this site, which is given in the home page. So I will discuss about the engineering mechanics. So what is mechanics? Mechanics deals with the forces acting on bodies which are at rest or in motion. So force is action of one body on the other. It may be push or pull. So point of action, direction and magnitude is very important. So what is the need of knowing mechanics? So mechanics, it deals with the forces. So mechanics is of rigid bodies is there, in which we study statics and dynamics, and in dynamics we study kinematics and kinetics, and there is also mechanics of deformable bodies and mechanics of fluids. In rigid body mechanics, we study the external effect of forces on bodies such as velocity, acceleration, and displacement, etc. And when we study the internal effect of forces on bodies such as stresses, internal resistance, change in shape, so this is deformable body mechanics. Next is rigid body mechanics. In rigid body mechanics, there is a negligible deformation or no deformation under the action of forces, and assuming 100% strength in the material, large number of particles occupying fixed positions with each other. Actual structures and machines are never rigid under the action of external loads or forces, but the deformations induced are usually very small, which does not affect the condition of equilibrium. Now, particle mechanics, in this particle mechanics, we treat the rigid body as a particle which is negligible in size when compared to the study involved, and all the forces should meet at a point, like forces acting on a hook. This is an example. In statics deals with the forces and its effects when the body is at rest, like in truss bridge, and in the dynamics, it deals with the forces and its effects when the body is in moving condition, like in IC engine, internal combustion engine. So this is the case of dynamics. So statics of particles, and all the forces are meeting at a point, and the pillar is in equilibrium under action of these three forces. And statics of rigid body, forces are acting at different locations. The shaft is in equilibrium under the action of several forces. And dynamics of particle, suppose two automobiles A and B are approaching each other in adjacent highway lanes. To analyze the geometry of motion, they can be treated as particles. And the dynamics of rigid bodies is when the rigid body is in general plane motion, the velocity and acceleration of various points on a rigid body are not same. So forces on a particle is there if force acting is there, so it can be resolved along x-axis and y-axis. So along x-axis, it can be represented in vector form as f is equal to fxi plus fyj, where I and j are the unit vector along x and y axis respectively. So fx can be written as f cos theta and fy can be written as f sin theta. So we can add all the forces along x and y axis. So sigma fx is equal to rx and sigma fy is equal to ry. So summation of all the forces along x axis is equal to rx and summation of all the forces along y axis is equal to ry. So we can find the equilibrium of a particle when the resultant of all the forces acting on a particle is zero. The particle is in equilibrium. So in the equilibrium conditions, R is zero. That means summation of all the forces is equal to zero, which implies sigma fx zero, sigma fy zero, and sigma fz also zero. Sigma fx zero means summation of all the forces along x-axis is equal to zero, and sigma fy means summation of all the forces along y-axis is equal to zero. So if a force is acting in a space, then we can resolve the force along x, y, and z axis respectively. And F is nothing but a square root of fx square plus fy square plus fz square, where fx, fy, and fz are the component of force along x, y, and z axis respectively. So if force F is acting, so its component along x axis is F cos theta x, its component along y axis is F cos theta y, and its component along z axis is F cos theta z. So it can be represented in a vector form like fxi plus fyj plus fjk, where I, j, k are the unit vector along x, y, and z axis respectively, and theta x and theta y and theta z are the angles with x, y, and z axis. So lambda here it is a unit vector. So unit vector has a magnitude 1. So we can write lambda x is equal to cos theta x, lambda y cos theta y, and lambda z cos theta z. So if force vector can be represented like here, we can say here that force it is a vector. So vector is multiplied, vector can be represented as the magnitude of force multiplied by the unit vector. So this is nothing but our unit vector. This is lambda. So suppose that we have to find in this question, determine the x and y component of each of the forces as shown. Like 60 pound force. So we have to resolve this force along x and y axis. So its x component will be 60 cos 25. 60 cos 25 is the x component, and the y component is 60 sin 25. 60 sin 25. So this is our y component. Similarly, we can resolve this 40 pound force along x and y axis. So this component along x axis will be 40 cos 60, 40 cos 60, and y component will be 40 sin 60. So we can see here that x component is positive and y component is negative. Similarly, we can resolve 50 pound force along x and y axis. So its x component will be like this. So it will be, so this angle will be 40 degree. So we can resolve along x axis as 50 cos 40 and 50 sin 40 along y axis. So this component will be 50 sin 40. Note that the direction of this is, this will be negative and this is also negative. And this will be positive, this component, and this component will be negative, y component. So if we add all the forces along x and y axis, so we can find it in table. So this is the fx, fy, all these things. So we can write in a table. So Rx is nothing but 36.08 and Ry is minus 41.4. So R can be written as Rxi plus Ryj. So this is the resultant force. So it is coming out to be 54.9 pound. Why? Because we are taking the square of 36.08 and the square of 41.42 minus 41.42 square of this. So this will be your R. In this way we can find the resultant force. Similarly, in this question also we have to resolve along x and y axis. So 80 Newton force is there. So its x component will be 80 cos 40 and y component will be 80 sin 40. Similarly, for 120 Newton, its angle with x axis is 70 degree. So its component is along x axis will be 120 cos 70 and its y component will be 120 sin 70. 120 sin 70. Similarly, for this 150 Newton force, its x component will be 150 cos 35, which will be negative, and y component will be 150 sin 35. 150 sin 35. So after this we can add all the forces Fx and Fy in a tabular form. So Rx is coming out to be this and Ry is coming out to be this. So R can be represented in a vector form like R is equal to Rxi plus Ryj. So if you take the square root of this and this, you will get resultant force as 251 Newton and angle is tan alpha is Ry by Rx, so we can get alpha is 85.293. So we will study the law of sine. So law of sine states that A by sine is equal to B by sine T is equal to C by sine C, where A, B, C are the sides of the triangle and A, B, C are the angles of the triangle. So we can prove it by simple trigonometrical relationship. So we can see here this in this triangle. Let us say this is the triangle. So in this triangle, if you take sine of A will be nothing but h by b. So we can write h is equal to b sine A. And similarly, we can take another triangle. Let us say this triangle. We are taking this triangle. So in this triangle, we can see here that sine of b is nothing but h by a. So we can write h equal to a sin b. So this is the first equation and this is the second equation. So we can equate 1 and 2, equation 1 and 2, because the right hand side is same. So we can equate b sin is equal to a sin b. So we can get a by sin is equal to b by sin b. In the same way, we can prove it that a by sin a is equal to b by sin b, which is also equal to c by sin c. So this proves sine rule. So based upon this, some question is there. Like two cables are tied together at C and loaded as shown. So P is 500 Newton, alpha is 60 degree. Determine the tension in the cable AC and BC. So we can write the free body diagram and force triangle. So this P is acting at an angle of 60 degrees. So 500 Newton, P is acting. So this 500 Newton is acting at an angle of 60 degrees. So we will make a line parallel to this force, making an angle of 60 degree with the horizontal. Similarly, AC is there, which is making an angle of 45 degree with the horizontal. So we will draw a line parallel to AC like this. So TAC making an angle of 45 degree with the horizontal. Similarly, BC is there, making an angle of 25 degree with the horizontal. So we will draw a line parallel to BC. So this is TBC, making an angle of 25 degree with the horizontal. Now we can apply the sine rule. A by sine is equal to B by sine B is equal to C by sine C. So in this triangle, so we can write TAC by sin 35 is equal to TBC by sin 75 is equal to 500 by sin 70. The angles can be found using simple trigonometrical relationship like angle sum of angle of a triangle is equal to 180 degree. Like this we can find out. So we can find out TAC and TBC like this. Now the next question is like a sailor is being rescued using a boat's swing chair that is suspended from a pulley that can roll freely on the support cable ACB and is pulled at a constant speed by cable CD, knowing that alpha is 30 degree and beta is 10 degree, and the combined weight of both swan chair and the sailor is 200 pounds. Determine the tension in the support cable ACB and in the traction cable CD. So we can write, we can resolve like sigma fx is equal to 0. So we can resolve like this is your TACB. So if we resolve this TACB, this force along x axis, so x component will be nothing but TACB cos 10 degree. And similarly, we can resolve this force TACB, x component TACB cos 30 degree, so it will be minus, and then TCD, x component will be TCD cos 30, so it will be also minus, so it is equal to 0. Similarly, sigma Fy is equal to 0. Summation of all the forces along y-axis is equal to 0. So if we resolve all the forces along y-axis, so it will be TACB sin 10 degree. For this y component will be TACB sin 10 degree. So this is TACB sin 10 degree, and if we resolve this force along y-axis, so it will be TACB sin 30 degree and TCD sin 30 degree, which will be equal to 900. So if we solve these two equations, we can get TACB and TCD like this. Okay, so the next theorem is Lami's theorem. Lami's theorem states that if the three concurrent forces are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. So if force F1 is acting along this, F2 is acting along this, F2 is acting along this, and F3 is acting along this, and they are making an angle of, this angle is theta 2, this angle is theta 1, and this angle is theta 3. So we can write that if I take F1, then we have to take the angle between F2 and F3. So this is sin theta 1. So F1 by sin theta 1 will be equal to, if I take F2 force, then I have to take the angle between the other two forces. The other two forces are F1 and F3, and the angle is theta 2, so it is nothing but sin theta 2. So this will be equal to F3, then the angle between the other two forces are, if I take F3, then the other angle is angle between F1 and F2, which is theta 3, so it is equal to sin theta 3. So this is the Lami's theorem. So we can write, we prove it, F1 by sin theta 1 is equal to F2 by sin theta 2 is equal to F3 by sin theta 3. So the converse of Lami's theorem is that if the three forces acting at a point are such that each force is proportional to the sine of the angle between the other two, then the forces will be in equilibrium. Or in other words, we can say that the force divided by corresponding sides are equals. Like F1 divided by the side is acting is along OP. So F1 by OP is equal to F2 by F2, it is acting along OQ, so OQ is equal to F3 by OR. This is F3, so it is F3 along OR. So this is the converse of Lamis theorem, and it can be proved using simple mathematical relationship like this. Now the question is based upon this, that a collar A is connected to a 50-pound load and can slide on a frictionless horizontal rod. Determine the magnitude of force P required to maintain the equilibrium of the collar when x is equal to 4.5 inch and when x is equal to 15 inch. So we can solve it like a free body diagram. So we can see here that at point A, this is force is pulled by P and this is 50 pounds. So this is a right angle triangle and the side is something like this. We can write this is a right angle triangle and this is 20 and this is 4.5. So the hypotenuse will be root 20 square plus 4.5 square. So we can write as which is nothing but 20.5. So force P divided by side is nothing but 4.5 and 20 this is there, so and 50 Newton 50 pound force is there, so 50 divided by side is 20.5. So we can get P is equal to 10.98 pound. Similarly, for the second case, when x is equal to 15 inch, so in that case also this is 15 and this is 20, so the square root of 15 square plus 20 square is nothing but 25. So P by 15 is equal to 50 by 25, so we can get P as 25. Now the next question is, three cables are used to keep a balloon as shown. Determine the vertical force P exerted by the balloon at A, knowing that the tension in the cable ADP is 480 Newton. So in this question, we have to find first AB vector, AC vector and AD vector. Then we can find the TAB vector, TAC vector and TAD vector. So first we have to find the AB vector. How to find the AB vector? This is origin O, so this is A, so this is y axis. So we can write OA vector as nothing but this distance is 5.6, so this can be written as 5.6j. Since this is along y-axis, so we can write 5.6j, and if I write OB vector, so the OB vector will be, it is along negative x-axis, so it will be minus 4.2j, minus 4.2i, because it is along x-axis. So now we have to find AB vector. How to find the AB vector? So this is our origin O, this is our OA vector, and this is our OB vector, and we are interested to find AB vector like this. So we can write OA plus AB vector is nothing but OA plus AB is nothing but OB vector. So we can write AB vector as nothing but OB minus OA. OB minus OA. So OB minus OA will coming out to be how much? So the AB vector is coming out to be minus 4.2I minus 5.6J. So therefore it can be seen here that it is AB vector is written minus 4.2I minus 5.6J, and the magnitude of AB is nothing but a square root of 4.2 and 5.6 square minus 4.2 and minus 5.6 square, so which is coming out to be 7. So this is the magnitude. Similarly, the magnitude of AC is 7.4, AD 6.5. Now we can write tension AB vector as the magnitude of this TAB multiplied by the unit vector along AB. So we can write like this. So we can multiply this with the unit vector which we have calculated already, AB. So we can write like this. Similarly, AC and AD. So we can write equilibrium condition sigma F is equal to 0. So we can add all these forces plus Pj. Why Pj? Because it is noted that the tension in the cable AD is 481 meter. Okay. So therefore we can write like this: TAB plus TAC plus TAD plus Pj is equal to 0. So we can substitute all these things, so we can get like this. Now we will equate the coefficient of Ijk is equal to 0. Why? Because coefficient of I represents summation of all the forces along x-axis. Coefficient of J represents summation of all the forces along y-axis, so it is nothing but sigma Fy, and coefficient of K represents summation of all the forces along z-axis, so it is sigma Fz. And the equilibrium condition says that when a body is in equilibrium, then sigma Fx is equal to 0, sigma Fy is equal to 0, and sigma Fz is equal to 0. So we can equate to 0, so we can get all this TAC and TAD. So if TAC and TAD, setting TAD is already given to you that it is 481 Newton. So TAD is 481 Newton. So we can get all the 6 TAC and TAD like this, setting this values. So we can get the what is the value of P. So the P is that the vertical force exerted by the balloon at A. So what is the vertical force exerted at balloon A? That is P, which is unknown. So we have to find this value P, knowing that the tension in the cable AD is 481. So we can find like this. So we can get P as 926 meter. Okay. Thank you.